what we're looking at today is matrices. We're starting matrices. We're not going to do a whole lot with them, but we will do more of them in 1-7. Now, a matrix is a rectangular arrangement of numbers. Now, it can be square, it can be rectangular. Now, the dimensions of a matrix are noted as rows and columns. The number that we have going up and down is rows. The number left and right is our columns. So this here has 2 rows and 3 columns, so we call it a 2 by 3. Rows number always goes first, columns goes second. Now, one of the matrices we're going to be looking at in particular is called an augmented matrix. And the way we get an augmented matrix is by taking a system of equations. So this one here, you don't have to write it down. We'll do some of these here in a minute. And taking the numbers in front of the variables, so the first one, 5, 3, -2, and lining them up here. And then we set what it's equal to. And we do it with each one. Now, one of the key things with this is that we need all the variables in all 3 or any of the equations that we have on the same side, and the number that doesn't have a variable on the other side of the equal sign. Then we can write a system of equations as an augmented matrix. So this is the first one we're going to look at, is writing an augmented matrix. So we have 2 equations here. All the variables are on the same side because the first equation we have y and x on the same side, our number on the other. The second equation we have x and y on the same side and our number on the other. But the other key piece of information that we need is that the variables need to be arranged from left to right in alphabetical order. So if we look at the second equation, it's already in the form we needed, x plus 3y equals 12. I'm just writing it out to the side so we can have it lined up. Now the first equation, y is first. We need the x to be first, yes? So we need to switch them. So I need to move the -2x to the front. Our positive y is second, and it's equal to 1. Since they're already on the same side of the equal sign, we can just rearrange the order. But we do need to make sure the signs are correct. Any questions on anything we've done so far? Now we're going to write the augmented matrix. So we take the coefficients, the numbers in the front of the variables, and then the number itself. So our first number is going to be what? -2, followed by 1 from the y, and then it's equal to 1. So our first row is -2, 1, 1. What's the next one going to be? 1, 3, 12. So for this system of equation, our augmented matrix is the matrix -2, 1, 1, 1, 3, 12. Now, how many rows do we have? How many columns? So this is a 2 by 3. Questions on this here? Any questions on anything we've done so far? We ready for the next one? That's it, yeah. So, hopefully, because this is the augmented matrix, and that there's the dimensions. If we look at the next one, are both equations written in the correct form? All right, the bottom one's xy equals number. Alphabetical order.
I don't know why, but I thought y was before x.
So 2x minus y equals 5 is fine. We need to rewrite the first one, and it would become what? 4x plus 3y is equal to 13. We don't have to put a sign out in front of 4x because since it's positive, no sign is understood to be positive. Now let's write the augmented matrix. So what would we have for the first row? 4, 3, 13. Our second one would be 2, -1, 5. Since we have -y, it would be -1. We have to take the negative with it. And what's our dimensions going to be? Because the number of rows we have is 2, The number of columns we have is 3, so it's A2 by 3. You don't necessarily have to do the 2, 3. I'm just writing those down so that you can see and count the numbers. And dimensions is always going to be down and over, rows by columns, going down, going over. We can also do this with 3 variables, x, y, z. So looking at these 3, are all 3 set up correctly? Top one's not. What's wrong with the top one? Right, the z is not in the correct order, but more importantly, it's on the wrong side, yes? So I'm going to write this out to the side. Okay. So what can we do to get it on the correct side? Yes. Yep.
$1 worth of suckers here.
10.
Kids gonna be happy.
10 of them.
All right. Let's see what we got. I should have brought some glasses.
So
Bye.
So looking at this here, on the previous ones, we could just rearrange it and be just fine because the x and y on the first 2 were on the same side of the equal sign, yes? Here we've got to move it, and if I'm going to move it, we have to, yeah, here we'll have to add it because the 2z was negative. We have to add it, giving us 3x minus 4y plus 2z is equal to 7. Because if it had been 7 plus 2z, we would have subtracted. Well, we're not looking at that one anymore. We're looking at the other one. So now is it in the correct form? Questions? Good? Because the main thing we want is it in the form of x, y, z. And it'll make more sense here in a little bit. But we want them in this form. So if we're going across the top for this first equation, what's our first number? 7. The next one. So 9, 3, yes. What would be our next number? Because what are our variables? We're going x, y, and the third one is z. It would be 0 because we do not have a z, so we fill it in with a 0. If we have a variable missing in one of the equations, we fill it in with 0. And then this is equal to 3. And the last one would be -1, 2.
Oh, oops.
And what are the dimensions of this one here? 3 by 4 because we have 3 columns, 4 rows. Now, adding a 0, we only have to add a 0 in for a variable if it shows up in at least one of the other 2 equations. So we only have to add a 0 if it shows up in one of the other 2 equations. Because if we look at the previous one, this here, is there a z listed in either equation? No. So we don't have to, and we're not going to put in another column, another row, another column here of zeros because there is no variable z in either one. If one of them has a z, the others have to have a value for z also. But if it's not there, we're not including it. Does that make sense? Okay. Let's look at the next one. Do we need to adjust any of these equations? So what would our first one be? 1, 5. Our next one. And our last one. 8, -3, 1, 5, 2, 1, 4, 2, 9, -7, -3, -6. What are our dimensions? 3 by 4. We ready for the next one? We're going to add something here in a minute, but we want to get used to doing these first. Do we need to adjust any of these here? Okay. So what would our first row be? I think this is doubled up. Here we go. 1, -8, -4. Our next one would be, and this is a 2 by 3. How about the next one? What about the top one? We need to add z to both sides. And if we add z to both sides, we get x plus y plus z is equal to. Okay. Now are all the equations set up correctly? So what are our numbers? 1. We got 1, 1, 1, 1. Then, and lastly, and this is a 2 by 4. Questions on any of this here? Are you ready for the next part? Solving matrices. Solving systems of equations using technology. So, 3 variable systems of equations. At this point, we know how to solve those, yes? Because that's what we've been doing the last 2 days, solving 3 variable systems of equations. We can use the graphing calculator to solve them. And what we want to do is we want the graphing calculator to convert this augmented matrix into something that we call reduced row epsilon form. And what that means is that this part here, we get what is called the identity matrix, this diagonal of 1s, and it actually does give us our solution. As with 3 variables, we put the number in front of x first. So that first column are all the ones that have x's. The middle is y, and the third one is z. So what this is telling me in the first one is that I have 1x plus 0y plus 0z is equal to -1.4. But really, what is this telling me? X's value is -1.4. The middle one, we have 0x plus y plus 0z is, or tell me y is just 5.2, because the other are just 0. And we could do a similar thing for the last one, which realistically is just telling me z is 16. So for this here, our solution is this triplet. Okay. You ready to see how this works? These are the steps. Now, I gave you the steps here. And for this problem, I do have kind of this here, the printout pictures. But we're going to use this equation here, this system of equation, in the graphing calculator to solve it. Now, the first thing we need to do is write the augmented matrix. So how would we write the augmented matrix for this here? So it's right there.
Where's that at? Oh.
Yeah, I just have a ton of stuff added to it. 1, 1, 1, 2. Our next one would be, and lastly, and this is a 3 by 4, yes? questions on how we set the augmented matrix up or found its dimensions? All right. You can grab the calculator and turn it on if it's not turned on already. Clear all that out. Clear the bottom here. Now, I cleared it out so the key press history down at the bottom of the screen is going to show you kind of a running tally of our strokes or keystrokes. Now, the first thing we need to do is hit second matrix. Second x to the negative 1. So we have a screen similar to this here. You might have different 2x3, 3x4s running down the list, but you do have something similar. So 1 through 9, A through I in brackets, yes? This, the 3x4, 2x2, 2x2, and 3x4, that might be different, but does everything else look the same? So you went second x to the negative 1, yes? So it looks something like this here, yes? Does, again, so one more time. The 3x4, 2x2, 2x2, and 3x4 may not be there, but is everything else there? Yeah. Yes, okay. So this here, this first section is matrices we plugged in. If it has a dimension next to it, it means there's a matrice there. We can use it and recall them here. But what we want to do is we want to edit. We want to go over to edit. And we want to edit the matrix. Now, we're going to edit the first one. So we'll hit enter. And you should get something that looks like this here. Second matrix. Now we're going over to edit. And we're going to hit enter. So we're going to edit the first one. Now the top two numbers are our dimensions. Now the dimensions that we want are what? 3, 4. So we hit 3 and then we can hit enter, 4, we can hit enter. I use enter to skip over to the next one. We can also use the arrow keys. The arrow keys will let us move around. Now we want to put the augmented matrix in. So our numbers for the first row were what? 1, 1, 1, 2. It may not show the whole matrix on your calculator. It only probably will show 3 columns and rows at a time. But if you keep moving over, it will give you space. Now we're going to go on and fill the whole thing in. 2, enter, 3, enter, enter, 3, enter. 1, enter, negative 1, enter, negative 2, enter, negative 6. So hit enter. Yep. Yeah, so you're just typing this thing in. So you can hit enter. Yeah, so we're typing this in. 2, then next row. Yep, so right there should be a 2, then So each time you hit enter, it will move to the next cell, the next number in the matrix. Once you get it all typed in, go second mode. Enter. Yep. So enter. So 1, 2. Enter.
1, negative 1.
Negative 6. Has everybody got the matrix completely typed in? Second mode. Second mode. Second mode. So we're going to quit back to the home screen. Now at this point here, what we want to do is go second matrix again. So if we did press A or we told it this here, it would pull up the matrix we just plugged in. But what we want to do is go over 1 to math. And what we're going to do is we're going to scroll down and find RREF. RREF. Whenever you find that and have it highlighted next to it, hit enter. So this is the reduced row epsilon form. So we all to this point. Before we hit enter, we're going to go second matrix because we need to apply this to a matrix. We type the matrix into matrix A. So we should have RREF A.
What did you do to get there?
Second matrix enter.
Wait, what's it?
Second matrix enter.
Okay. Yeah. I didn't push it.
So we recalled it. Once you get this here, press enter one more time.
What?
Press enter one more time. Do we have this here? Go on and hit enter. So you have this here, yes? So you don't have to rewrite it. I'm just rewriting it so we can see it. So like we saw with the previous one where I showed you the one that they gave us in the notes, x equals y equals z equals. What this is telling us is that this is x, this is y, this is z, or that our solution for this 3-variable system of equation is -1, 1, 2. Yep, that is the answer. Huh? To actually find the solution. So what we did yesterday in class and what we did Tuesday, yep. This is the answer. So what we did Tuesday and yesterday, not Tuesday and yesterday, Monday and Tuesday, what we've done all week solving those 3 variables, we just did right there. So again, the more that you get used to this, and especially typing these in, you're going to get faster. We're going to do, so these are the steps. Let's do another one. So we'll go through doing that here in a minute. Augmented matrix, let's start off by writing it first. So what would be the numbers across the top?
2, 3,
15. Then our next row is
9,
-12. And the last one, 4, -1. And this is still a 3 by. All right, we're going to grab the graphing calculator. So the first thing we need to do is put this matrix in. So we can go second matrix and over to edit. And we can hit enter. Since we only are dealing with one matrix at a time, we can just always put it in A. So we're saying still 3 by 4. Now the first number this time is 2, then 3, -1, 15. 3, -9, 9, -12. 4, -3, -1, 19. Once you get used to these, it's going to be a lot easier, and you'll get a lot faster with it. Once you get it all the way typed in, do second mode, second quit. Has everybody got the count or graph or matrix typed in? Yes. Second. What we're doing next is second matrix. This time we're going over to math, and we need to find RREF, yes? I will tell you that there's 2 ways to get it. One is going down, and the other is we can go up. RREF. So we get this here. Now we need to put matrix A next to it so that it applies our reduced row epsilon form to it. So second matrix A, enter, we get this here. So what is our solution? Yes. And that's the solution.
What I did.
Second, let's look at the matrix. Second matrix. Edit 3 by 4. So you have 2, 3, negative 1, 15, 3, negative 9, 9, negative 12,
Probably why. Oops.
4, negative 3, negative 1, 19.
Okay, yeah.
Yep. And that's it. Questions on any of this here? See where we're at. We're doing great on time. So what do we think about these so far?
A lot easier than past 4 days.
So as that loads, so now again, the question I get every year with this is why didn't we do this first? This, we went through the process of solving these by hand because I wanted y'all to get an understanding of how we solve these and how solving these works, what we're actually finding. Because once we get an understanding of how to solve them, then we'll have an understanding of how this works, or kind of the background.
No, the homework before this.
Now, we are going to do, I want to do this one here. And we're going to have some time to work on these also tomorrow. Now, I want to show you this one here. So you can follow along with me, especially typing it in. But this one we already did. This was from the notes yesterday. And if this one looks familiar, there is a reason why. Now, also, when we do this, and you get a little more used to it, especially knowing how to type them in, you might not always have to write the augmented matrix, especially if you know how the numbers go. So 3 by 4. Now the matrix we have is 1, 1, 1, 2, 5, 5, 5, 3, 4, 1, negative 3, okay, negative 3, negative 6. Now, one of the things that is very helpful is the DEL key. That's just delete. So if you have it, the cursor over a number that's not supposed to be there, you can hit delete and it'll delete it. It's a little bit better than clear because clear will clear everything. Now, one of the other nice things with the graphing calculator is wherever the cursor is at, if you put it over the top of a number, it'll automatically delete it. If you've ever used the insert key on a keyboard, have you all ever hit that by accident? And it just starts inserting everything over the top of it, not moving. The calculator kind of stays in that mode. Now, that can quit once you get it typed in. I will show you this here. Because we can go, again, second matrix over RREF, enter, second matrix A. I can go up and select this and bring it down. Because did we change what matrix A was? Well, yes. So if I hit enter again, I'm not going to get the previous matrix. I'm going to get a new matrix. Now, I don't like those decimal numbers. So did we all get something that looks like this here?
I did.
got negative.
Hit math. Do you see what the first option that it gives us immediate is? Arrow fraction. So if you hit enter, it says answer, so it's going to take the previous answer we got, hit enter again, and turn them all into fractions. Now the biggest thing I want to bring your attention to is the bottom row. We have all zeros and a. So that last row, what it's telling me, so let's get a writing utensil. 0, 0, 0, 1. I'm going to go back and get the rest of it. Negative 4/3, 7/3, and zeros. We get this here, yes? Well, the top row, because again, x, y, z equals our number. So the top one's telling me x, we don't have y, but we have negative 4/3 z is equal to 0. I have an equation. The second one is telling me I don't have x, but I do have 1y plus 7/3 z is equal to 0. So we have two equations, that's fine. But if I look at the bottom one, well, I have 0x, 0y, 0z. So this entire side of the equation is, and what is it equal to? Is this a true statement? So this is no solution. Because if one of the lines has all zeros and then number, it is no solution. All right. I'm going to do one more. I'm going to just put this one up. So I'm going to recall it enter. Okay. This one here is a little different because what is the bottom row for this one? All zeros. So unlike the last one, this is actually giving us a true statement, 0 equals 0. So, and that's this one here. We did this one the other day. 1, 0. I'm going to have to negative 1, 1. Yeah, well, this is from the note sheet. So this is the note sheet yesterday, because this one here we solved. We found that it was infinitely many solutions. And part of the reason we know it's infinitely many is this bottom one is telling us 0 is equal to 0. All real solution, not all real, infinitely many solutions. Now the top equation is telling me that x minus y is equal to negative 3. The second one is telling me that z is equal to 0. Okay? Now again, I said the other day that infinitely many solutions, we can actually have numbers or systems that work for it, and not everything will. Only some things will. Well, the value of z has to be 0. That's what it told us. This other equation, x minus y equals negative 3. I'm going to solve it for x. Add y to both sides, telling me x is equal to y. This is note sheet from yesterday. This is above and beyond. Because again, when I told you all yesterday that we want, for this here, we just say infinitely many, that's all I'm going to take. Now, realistically, what we can do is have this here. So x I have defined as y minus 3. And our y value is just y. And this here is the solution, the infinitely many solution. So one of y'all give me a value for y. 4. So we could say 4, comma 0. Well, the first one's y minus 3, yes? Well, y is. So 4 minus 3 is? I can put any number for y and then simplify the others to get there. So this is a point. So if I looked at the first equation, 140, I'd have 1 minus 4 plus 0 is equal to negative 3. Well, 1 minus 4 is indeed. The next one, we have 1 minus 4 minus 0 is negative 3. Well, yes, that's pretty much the same as the first one. Last one, 5 times 1 minus 5 times 4. I need to click both sides. Plus 0 is equal to negative 15. Well, 5 times 1 is 5. Minus 20 is equal to negative 15. Yes. Any value I plug in for y will be true for all three of these equations. That's why it's infinitely many, but it's not all real, because if I change this z from 0, it's not going to work. There are going to be some that might work, but they might not work for all three. So this is the equation set up for us to be able to find the infinitely many solutions that do work. Does that kind of make sense? I'm not asking you to take it this far. If we get all zeros on the bottom, do make sure to check the second row that it's not all zeros equals 1, because then it's no solution. But this works. We'll look at more of these tomorrow.